Hello, we are Group A12 from BEE QK 1013, Introduction to Mathematical Economics. These are our team members and their matrix number.
Hello everyone, we are from Group A12. Today, we are excited to present our assignment. But first, let us introduce ourselves first. Starting with me, my name is NOOR DANIA SYAFIQA BINTI ROSDI, which matrix number 313866. So today, I would like to present my part, which is question A and question B. But first, let's see question A first. Question A, we are given three equations. First, we have y equal to c plus I naught plus g naught. Okay, that's for the first one. For the second one, we have c equal to c naught plus byd. Third, we have t equal to t naught plus ty. Okay, so we also know that yd is equal to y minus t. So what we need to do, we need to substitute y minus t into yd. If we look at the equation given, only second equation that have byd. So only equation 2 that we need to change in this question. So t equal to c naught plus byd. If we substitute, we get c equal to c naught plus b times y minus t. Okay, therefore, for the final answer, we have three equations, which is y equal to c plus I naught plus g naught. For the second one, we have c equal to c naught plus b times y minus t. And for the last one, if we have t equal to t naught plus ty. Okay, let's move to question B. For the question B, we know that these three equations we already do in question A. So what do we need to do in question B? We need to move y, c, and t to the left hand side. Okay, so for the first equation, we have y equal to c plus I naught plus g naught. So we need to eliminate c on the right hand side. So we need to minus c on the both side. So we have y minus c equal to I naught plus g naught. Okay, for the second equation, we have c equal to c naught plus by minus bt. We need to eliminate by minus bt. So we need to minus by plus bt on the both side. So we have, for the final answer, we have c plus bt minus by equal to c naught. For the last equation, we have t equal to t naught plus ty. So we need to eliminate ty on the right side. So we need to minus ty on the both side. So we have t minus ty equal to t naught. Next, what we need to do is to take the coefficient of y, c, and t from each equation. For the first equation, we have y equal to 1, c equal to negative 1, and t equal to 0 because we don't have t here. Okay, for the second equation, we have y equal to negative b, c equal to 1, and t equal to b. Okay, for the third equation, we have y equal to negative t, c equal to 0 because we don't have c here, and t equal to 1. Okay, so we need to form a matrix form. We use A as equal to B. When A is coefficient of the matrix, X is the vector of the variable, and B is the constant vector. So we need to max this all these three into this one, is into the matrix form. So for the final answer, we got this matrix form.
Hi, good morning to Dr. and my fellow friends. My name is THARAHNI and my matrix number is 310081. So today I'm going to solve the y, c and t using a matrix inversion method. So in order to solve the system of equation using the matrix inversion method, we apply the formula that x equals to 1 over the determinant of a multiplied by the adjoint of a and the constant vector. Before we can solve for the unknown variables, it is necessary to first determine two key components, which are the determinant of a and the adjoint of matrix A. So let us begin by finding the determinants of matrix A. So the matrix A is a 3 by 3 matrix, and we compute its determinant by expanding along the first row. So the first element is the first row is 1. We multiply this value by the determinant of its corresponding 2 by 2 minor matrix, which is formed by deleting the first row and the first column. Next, we consider the second element in the first row, which is a -1 according to the determinant expansion rule. We subtract this value multiplied by the determinant of its minor matrix. The third element is the first row is 0. Since any value multiplied by 0 equals to 0, this term does not contribute to the determinants and can be ignored. So after evaluating the determinants of the minor matrices and simplify the expression by obtaining the determinant of A as 1 minus B times 1 minus T. This result is important because the determinant determines whether the matrix is invertible. Since 1 minus B times 1 minus T is not equals to 0, so we can conclude that matrix A is invertible. Therefore, the inverse of A exists, and we can proceed to compute the adjoint of A and ultimately solve for an unknown variables using the matrix inversion method. Next, we have to find the inverse. So before we find the inverse, we need to find the adjoint matrix of A. So this process actually involves three main steps, which is the finding the minors, creating the cofactor matrix, and finally transposing the matrix. So finding the minors, first we calculate the minors for each element. So we do this by calculating the determinant of the 2 by 2 matrices remaining after we cross out the row and the column of a specific element. So for the first row, we find the value for M11, which is 1. For M12, which is negative B, we times with 1 minus T. And M13 is T. And for second row, you will get second row, 21 is negative 1, M22 is 1, M23 is negative T. So for the third row, M31 is negative B, M32 is B, M33 is 1 minus B. Yeah, so once we have this minus, we apply the cofactor sign pattern, which alternates the plus and minus to form the cofactor matrices. So as you can see, the center column, we have organized our calculated values in 3 times 3 grade. This represents the row matrix before its final transformation. And lastly, the final step to reach the adjoint of A is transpose the cofactor matrix, which means that we have to flip the matrix over its diagonal, turn our rows into columns. If you look at the final matrix on the right, labeled as equation 1, our first row from the cofactor matrix has now became our first column. So this resulting in matrix adjoint A is what we will use in the next slide to solve our variables. For the construction of our adjoint matrix to the actual solution, we now apply the core formula of the matrix inversion method. To find the inverse of matrix A, denoted as A inverse, we use the A inverse. The inverse of A is equals to 1 over the determinant of A multiplied by the adjoint of A. Essentially, we are scaling every element of the adjoint matrix by the equal of the determinant we calculated earlier. So as you can see on the left side of the slide, we substitute our specific value into this formula, our determinant, which is 1 minus B times 1 minus T. So we replace that as the denominator outside of our 3 by 3 adjoint matrix. This gives us a complete expression for A inverse, which is the fundamental tool we need to solve for our unknown variables, which is income, which is for the Y, consumption, C, and T. So to find the specific value for our variables, we set up the equation, which is X equals to inverse times B. Here the X is our vector of unknowns, B is our vector of external constants, especially in I sub 0 plus G sub 0, C sub 0, and T sub 0. So now let's start with calculating Y. So the first element of our vector is by performing the dot product of the first row of our inverse matrix, with the constant vector, we get the expression shown. After expanding and simplifying the numerator, we arrive at the equation 2. First, let's look at the first derivation on the bottom left, labeled as equation 1 in the notes. So to find the national income, which is y, we perform a matrix multiplication between the first row of our inverse matrix and the constant vector. So first, we multiply the scalar of 1 over 1 minus b times the quantity 1 minus t by the result of our row-column multiplication. Inside the brackets, you can see multiple 1 by the sum of I sub 0 and g sub 0 and 1 by c sub 0 and negative b by t sub 0. So by combining these terms and rearranging for clarity, we arrive at the final expression for y, which is c sub 0 minus bt sub 0 plus with I sub 0 plus g sub 0 and divided by 1 minus b times 1 minus t. Next, we find out the c, which is labeled as the equation 3. So we use the second row of the inverse matrix. That means we take the determinant of A and then you times with the P times 1 minus T and times again with I sub 0 plus G sub 0. Then we plus with 1 times C sub 0 and minus B times with T sub 0. And you will get the final equation, which is the equation 3, which is c sub 0 plus b times 1 minus t with c I sub 0 plus g sub 0 and minus b t sub 0, and you divide it by the determinant, which we solve for the t, which will take the third row of the matrix. So we multiply, first we take the determinant of A, you multiply with the t, then you times with the I sub 0 plus G sub 0 plus T, and you sub 0 with C sub 0, and then you plus with 1 minus B, and then you times with T sub 0. The final answer you will get for the T equation is T times with I sub 0 plus G sub 0 plus C sub 0, then you plus with 1 minus B and times with T sub 0, and you divide by the determinant of A, and you will get equation 4. So here, final summary of our result, which is the equation 2, 3, and equation 4. Thank you.
Hi, my name is PRABAGARAN, matrix number 293786. So now I'm going to be explaining on question 3 part 2, which is to solve for the aggregate expenditure, the consumption, as well as the income tax using Cramer's rule. Now on the left hand side here, we can see that we have matrix A, vector X, as well as vector D. And this matrix is obtained from the previous question, which was question B. So now, what we want to do is, we want to use Cramer's rule in order to find the values for vector X, which is Y, C, as well as D. So Cramer's rule states that we need to use the determinant for A, J, and divide it by the determinant for A. Okay, so now let's start with the determinant for A. So in order to calculate the determinant for A, what we do is, we choose one value from one row of the matrix. So let's say I choose the value 1. And what we have to do is, we need to cover up the left hand side, and we have to cover the particular row and column that is related to the value 1. So in this case, it will be column 1 as well as row 1. And then what we have to do is, we need to multiply the diagonals for the point which is 1 times 1 and minus it by the diagonal for b times by 0. That's how we got 1 minus 0. And then we have to minus it with the next value, which is negative 1. Negative 1 will then times by the negative b times 1 minus b times negative t. And then lastly, we have to plus with 0, which will then multiply with negative b times by 1 and b times negative t. And once we compute that, we will obtain the value of 1 minus b plus bt, which can be further simplified into 1 minus b times by 1 minus t. Okay, so moving on. To find the determinant for a, y, what we have to do is, we need to replace the first column with the vector d. Now, as we saw in the beginning part, vector d was consisted of I naught plus G naught, and then we have C naught as well as T naught. So now we take that entire vector D and replace it in the column 1 of the matrix A. And what we obtain is, can be shown on the right hand side here. Once we substitute the value inside that, we calculate the determinant for A, Y, and we obtain the value of C naught plus I naught plus G naught minus B T naught. Now, in order to calculate the value of for Y star, we do what is we divide the determinant for AY with the determinant for A, and as you can see, we obtain the value for Y star will be C naught plus I naught plus G naught minus B times T naught divided by 1 minus B times by 1 minus T. Okay, now that we are done with AY, we move on to AC. Now the determinant for AC is computed using the same way, but instead of using the first column, we replace the second column with the vector D. And now this on the left hand side here shows the proper matrix with the substituted value of the vector D. And when we substitute the value inside that and calculate the determinant, we obtain the value of AC's determinant as C naught plus B T naught plus B times by I naught plus G naught minus BT times by I naught plus G naught. And in order to compute the C value for C star, we take the determinant for AC divide it by the determinant of A, and we obtain the value of C naught minus B times T naught plus B times I naught plus G naught minus BT times by I naught plus G naught. The whole thing will be divided by 1 minus B times by 1 minus T. Last but not least, we have to find the determinant for AT, which can be obtained by replacing column 3 with the vector D. And now that we replaced column 3 with vector D, we will have the matrix as shown on the right hand side. And once we calculate the determinant for AT, we obtain the value of T naught times by 1 minus B plus T times by C naught plus I naught plus G naught. And then we have to find the value of T star, which can be obtained by dividing with the determinant of AT together with determinant of A. And what we get is T naught times by 1 minus B plus T times by C naught plus I naught plus G naught. The entire thing will be divided by 1 minus B times by 1 minus T. So as you can see, the value for Y star, C star as well as T star is similar compared to the previous question. It's just that we are using a different method which is much more easier, which is called the Cramer's rule. And now I'll pass on to the next presenter.
Hello everyone. For question 3, I will solve for the equilibrium values of national income Y, consumption C, and tax T using the variable substitution method. Now we begin with our consumption function C equals to C naught plus B times Y sub D. Since disposable income Y sub D is simply what is left after taxes, or Y minus T, we substitute our tax equation T equals T naught plus T times Y directly into it. This gives us the expression C equals C naught plus B times the quantity Y minus T naught minus T times Y. After we expand the brackets and group our income terms together, we arrive at a simplified consumption formula. C equals C naught minus B times T naught plus B times the quantity 1 minus T, all multiplied by Y. Now I substitute this expression for consumption into the national income equation. Y equals C plus I naught plus G naught. So we have Y equals C naught minus B times T naught plus B times the quantity 1 minus T times Y plus I naught plus G naught. Rearranging the terms to isolate Y on the left side, we get Y minus B times the quantity 1 minus T times Y equals C naught minus B times T naught plus I naught plus G naught. Next, we factor out Y, which gives us Y times the quantity 1 minus B times the quantity 1 minus T equals the sum of our autonomous variables. Finally, by dividing both sides, we find the equilibrium level of income, Y. And Y equals to C naught minus B times T naught plus I naught plus G naught all over 1 minus B times the quantity 1 minus T. To finish our solution, we solve for the remaining equilibrium values using the tax function. We find T equals T naught plus T times Y, and using our simplified consumption function, we find C equals to C naught minus B times T naught plus B times the quantity 1 minus T times Y. In conclusion, by using the variable substitution method, we have successfully derived the equilibrium values for income, consumption, and tax. Thank you for your time.